Okay, this is the video for the group quiz, and this is scenario 2. So a company is considered implementing one of two quality control plans for monitoring the weights of automobile batteries that it manufactures. Um, if the manufacturing process is working properly, the battery weights are approximately normal. So as soon as I see approximately normal, I'm like, okay, need to focus on that. That's important. Probably going to be working with Z equals X minus mu, or Z equals an X bar. So either a Z score or standard deviation. I mean, not standard deviation, the sampling distribution of the sample means. With a specified mean and standard deviation, assume the manufacturing process is under control. Well, they didn't tell me the mean and standard deviation yet. So quality control A calls for rejecting a battery if it falls more than 2 standard deviations below a specified mean. So if it's more than 2 standard deviations, what that's going to look like is saying, you know what? I don't know what the mean is, but mean is 0, 2, and then I have a Z-score of 2. Anything below that -2, and I know it's negative because it's below the mean. So these are my Z-scores, and if it's below 2, then we're going to reject it. It says and then it says what proportion of the batteries will be rejected by plan A. So we want to know the probability that Z is less than -2. Well, that's pretty easy to do. I go to the calculator and I go second vars, norm CDF. I go to negative infinity and I can put a bunch of 9s in, and -2. Mean is 0, standard deviation of 1, because this is Z-score and they told us it was normal. So it just equals 0.0027. We want to always go to 4 decimal places and truncate. So 0.0227. Now, some people looked at this and could have done so by the empirical rule. If they'd done empirical rule, I still would need to see a picture or a label that says empirical rule. And I know that this area right here is 0.95, -2 to 2, mean is 0. And I would go, well, that's 1 minus 0.95, and I need to divide that by 2, and that would give me 0.025. And that would be by empirical rule. And I would at least need to see that you named it empirical rule, or that you've drawn a picture. And again, we were only looking for this area right here. So this is my 0.025. The other 0.025 is in this tail. We were only interested in the lower tail. Then it says, what is the probability that at least 2 of 7 randomly selected batteries will be rejected by plan A? Well, a lot of times they're going to use what you've done in part A to answer part B. So now we have a group of 7. And it says at least 2. So I sit there and go, well, that could be 0, 1, 2, 3, 4, ... all the way to 7. So at least 2 means that it includes all of these values, includes 2 through 7. So probably the easiest way for me to look at this is a 1 minus scenario. And also they kind of hinted at it. Because it says at least, and anytime they say at least, we're generally looking at a 1 minus. Since we have a specific number of trials and a specific probability, this is going to be a binomial CDF. And here's what we're gonna plug into the calculator: 1 minus the binomial CDF. And we're going to subtract out what we don't want. I want 2, 3, 4, 5, 6, and 7. So what I don't want is 1. Now, how am I going to show my work before I run that through the calculator? Well, I know for sure that I can do the PDF of all these values. So essentially we want the PDF of 2 plus the PDF of 3 all the way to the PDF of 7. So this case is going to be 7, choose 2, 0.0227, which I got from the previous, from part A. 0.0227 squared times 1 minus that. 7 minus 2 is 5, plus plus 7, choose 7.0227 to the 7th power, 1 minus 0.0227, 7 minus 7 is 0. This should say 0.0227 right there. I know that's pretty hard to read. Okay. All right, so that would have been work shown. So let's run it through the calculator. So 1 minus second vars, binomial, CDF, trials is 7, our p-value is 0.0227, and the x, remember, we're not subtracting out the 2, we're subtracting out the highest thing we don't want, which happens to be a 1. And we end up getting about 1 whole, or 0.01, excuse me, I said that wrong, equals about 0.0100, about a 1% chance of that happening. Now, a couple things, real important to know, show your work and to make sure that you're subtracting out what you don't want. And once again, this was a binom. It was a CDF. Our trials were 7 and our X value in this case happened to be 2. Well, that's a little tricky, so let's leave that off. Okay, so ignore what I just said there. All right, so once again, 1 minus the CDF of 1 because that's what we're subtracting out. Okay, all right. So under plan A, what's the probability the first battery is the third battery rejected? In other words, using the probability you got in part A, what would we do? And it says that the first rejected is the third. So we're talking about 1, 2, 3, 4, ... but we want to know specifically the third. So that means I'm working with PDF. And since it's the first, this is going to be a geometric PDF. And so basically, it can't be on the number 1. It can't be on number 2. It has to be specifically on number 3. So I'm going to have 3 blanks, 1, 2, and 3. This one is defective. This is not defective, and this is not defective. The probability that this is defective is 0.0227. Probability this is not defective is 1 minus 0.0227. And this is also going to be 1 minus 0.0227. So really, this could be summarized as 1 minus 0.0227 squared times 0.0227 to the first. Notice 2 plus 1 is 3 because this is going to be a geometric PDF, and our X value is going to be 3. So here we go. Second vars, geometric PDF, probability 0.0227, X value of interest is 3, and we get 0.0216. 0.0216. Please remember, need to see this work and like to know what the distribution is. Also under plan A, what is the probability the first rejected batteries among the first 23 batteries selected? So it could be the first battery is defective, the second, the third, ... all the way to 23. So if we're interested in multiple values, the fact that we're looking for multiple values makes this a CDF. Now it could be the first one, the second one, the third one. So this one, we don't have to do a 1 minus. This is just a geometric CDF. And to show our work, we're going to have to show our first and then our last. The probability that a defective occurred on the first one is 0.0227 plus ... plus 1 minus 0.0227 times 0.0227. And this will always be to the first power, and 23 minus 1 is 22, because these need to sum up to 23. So at this point, we can go back to our calculator. And we're going to go second vars, geometric, CDF, our P is 0.0227, and our X value is 23. And we end up getting 0.4102, right? 0.4102. And of course, some of that's going to be left to your rounding. And if you use the empirical rule version of 0.025, you would have gotten a different percentage, but nonetheless, still acceptable. All right, so this would be work shown, right here. Then we get to part B. What proportion of the batteries will be rejected by Plan B? Well, let's look at what Plan B said. Plan B said, under control Plan B for rejecting batteries as defective, if it falls more than 1.5 IQR ranges below the lower quartile. Wow, that's going back a ways. So in other words, if X is less than Q1 minus 1.5 IQR. So that's what we're going to reject. If X is less than Q1 minus 1.5 IQR. So I'm going to write that down. X is less than Q1 minus 1.5. And IQR happened to be Q3 minus Q1. Well, right there, that's a little bit of a hint. Q1 is at the 25th percentile. Q3 is at the 75th percentile. And Q1, again, is at the 25th percentile. Well, one of the things I have a problem with is I don't know what Q1 and Q2 and Q3 are, but anytime they give me an area, if they give me an app, I can calculate a z-score. So because they gave me an app, I can calculate a z-score. So I'm going to go second vars, inverse norm, 0.025, mean of 0, standard deviation of 1, and I get negative 1.599. So X, so this is going to be negative 1.95, and I'm going to 1.599 minus 1.5, and Q3, second vars, inverse norm, is 0.2. You know what? I have a problem here. I got to go back and fix this. 0.25. I had 0.025. Okay, that's better. Negative 0.6744. So this should be negative 0.6744. That's the IQ, that's the z-score for 0.25, minus 1.5. I need to do it for Q3. Second vars, inverse norm, make that 75%. And I get positive 6.744. Minus a negative 0.6744. So let's do a little bit of math here. Let's do this part inside inside the parenthesis. So we're going to have 0.6744 minus a negative 0.6744, and that equals a positive 1.3488. So I have negative 0.6744 minus 1.5 times 1.3488. So negative 0.6744 minus 1.5 times 1.3488 equals negative 2.696. Equals negative 2.696. So this is a z-score. If I get a z-score less than this, I'm going to reject. So basically, here's what we're saying. Here's 0, here's +1, etc. If I get a z-score that's less than negative 2.696, this will be my rejection zone. So I can do a norm CDF at that point, because I'm looking for the probability that z is less than negative 2.696. If I get, so I'm going to go to norm CDF, second vars, norm CDF, negative infinity, negative 2.696, mean is 0, standard deviation 1. And we find out that it's 0.0035. And what I should be seeing minimally for work is I should be seeing all of this. And then I should be seeing either a graph of this or some sort of plug-in for this, something along these lines. I really want to back up real quickly and just say this Q1 is just saying, hey, you know what? They gave us an area. They gave me this area 0.25, and I found out that this z-score was negative 0.6744. And then up here at 0.75, this is 0.6744, right? Because that's how we established our IQR, was that difference. Okay. All right. So that's scenario number 2.